Hi Calculus 1 students. In this video, we're going to do one of the last example of the section 2.6. So it's involving the limits at infinity of trig functions. Just a quick recap before we begin this example. We saw that most of the times the limit at infinity of trig functions do not exist simply because the trig functions just repeat themselves over time. So they're not approaching a single value, they're like oscillating. But in some cases, when the oscillations are being damped, meaning that the trigonometric function is like stuck between two functions that are both approaching 0 or any other value, then we can hope to find the limit using the squeeze theorem. And that's what we're going to do with this example. Okay, so the first thing to note is that there's more than one way to correctly solve this example. One thing you could do is to actually split the limit in two. You could say like, okay, this is the limit as x is approaching infinity of 3x squared divided by 2x squared plus 1 plus the limit as x is approaching infinity of 2x sine of x, okay, over 2x squared plus 1, okay? Of course, you can do that only if both limits exist, but you're always kind of assuming that both limits exist, performing all the calculations, and write your result at the very end. Now, this limit is quite easy, and this limit is easier than this one, right? So the idea is to split the big problem into two simpler problems. However, in this video, I'll take a different avenue that is as good, I would say, is I will do the squeeze theorem on this right from the start. Okay, so, but I just want to mention that solving it like this is good as well. So we will instead, there you go, use the squeeze theorem right from start. Okay. So what do? We take this big function, and what we try, the first thing we do is, what's giving us the problem is the trig function. That's why we're using the squeeze theorem in the first place, to see if the limit could exist. So we start by pinching this trig function between its natural values, -1 and 1. So we know for sure that sine or cosine are always stuck in between those values. And then what we do is we work our way up to the whole function at the top right here. So first thing we're going to do is we're going to multiply all sides by 2x. So I'm going to try to color code each of the steps in green. So we multiply by 2x. Okay, so we have here 2x sine of x. And then in here we have 2x, okay? And now what's important to note, so I think I will color code the inequalities in green, is that as x is approaching infinity, 2x is also approaching infinity, so meaning it's positive. And therefore, since we multiply all sides of the inequality by a positive number, the inequalities don't change. All right? The next thing we do is we add in this 3x squared. Okay, so we're having here 3x squared. Remember, what I color code in green is the new step. Okay, so I'm dropping the color code on this line. So I have here 3x squared plus 2x sine of x. And finally here I have 3x squared plus 2x. Okay. Now remember that adding or subtracting something to all sides of an inequality don't change its sign. So adding something doesn't change inequalities. As long as it's done on all sides, right? You need to read between the lines when I write something like this. Okay, so we can write this down. All right, we're almost done. Now the next step is to divide all sides by this. Okay, so let's do it. We have 3x squared minus 2x. And now what we're doing is we're dividing by this thing. So 2x squared plus 1. Okay, then we do the same thing, like 3x squared plus 2x sine of x. So that's it. We're dividing all sides. So we have here 2x squared plus 1, and then here 2x squared plus 1. Okay, and here what we need to take into account is that 2x squared plus 1, regardless of what x is, this is a positive number. So 2x squared plus 1 is positive, regardless of what x is. So meaning that, again, the inequalities don't change. All right, we're almost done. Now what we need to do is to take the limit, because now what we have this function. Okay, so actually let me color code this. It's important to realize that the purpose of doing it is really so to get the function that we need to take the limit of in the middle, right here. So now what we do is we take the limit of this and the limit of this. Okay, so let's see how I could color code them. I think I will do it in red and in black. Okay, good. So we take the limit of this as x is approaching infinity of 3x squared minus 2x over 2x squared plus 1. Okay, and to take this limit, basically you factor what's large. So x squared times 3 minus 2 over x divided by x squared times 2 plus 1 over x squared. Perfect. And then canceling the x squares that give you the problem, and then direct substitution gives you that the limit is 3 over 2. So unfortunately, as you can see, I need to erase this statement in order to finish the problem, but we're almost done. So let's erase this. Now let's tackle the black limit. Okay, we take the limit as x is approaching infinity of, so we have 3x squared plus 2x divided by 2x squared plus 1. So same thing, like you factor what's large. So in this case, it's going to be x squared at the top, 3 plus 2 over x. And then at the bottom, it's going to be x squared multiplied by 2 plus 1 over x squared. And then canceling the x squares, right? And direct substitution will give you 3 over 2. So what we discovered, and I will erase this just to write it down properly. So what we discovered is that the red limit, which is 3 over 2, is smaller or equal than the limit as x is approaching infinity of this function right here, like the 3x squared plus 2x sine of x over 2x squared plus 1, which in turn is smaller or equal to the black limit, which is 3 over 2. So by the squeeze theorem, you can easily conclude that the overall limit is 3 over 2. So squeeze theorem, the limit as x is approaching infinity of the middle part, so 3x squared plus 2x sine of x divided by 2x squared plus 1 is 3 over 2. There you go. Perfect. I hope this helped, and see you in class or in the next video.